place, Andover, Maine. It is the night of July 9th, 1962. What will tomorrow bring? Success or crashing failure? Telephone men drive through the lonely hills of Andover to make final tests on the electronic gear that may or may not find and communicate with a tiny spinning globe thousands of miles in space. In all too few hours, the satellite named Telstar will rise from a Florida beach.
All operators, man your stations and monitor conference 1.
The men of Andover are betting on tomorrow.
This is the director. Let's start the system status check.
System check for mission 1 starting at 22:45:37 UT. Command tracker report. Command ops ready. Precision track report. Precision track ready. TEG report. TEG ready. Data ops report.
Data ops ready.
Receiver report. Receiver ready. Transmitter. Transmitter is ready. Director, this is ground control. Come in, ground control. Ground control is ready. Roger. Director, this is communications control. Come in, communications control. Communications control is ready. Roger.
Poised on its rocket at Cape Canaveral is the incredibly complex globe, 34.5 inches in diameter. Telstar, waiting.
Status report from the horn. Antenna ready. Check.
Another horn focuses on the sky at Holmdel, New Jersey, the horn that first caught signals from the Echo balloon. In the pre-launch hours, a second group of telephone scientists make ready.
Receiver operating satisfactory. Calibrations? Calibrations normal. Check. Can I have the DAC report? Drive tape ready?
Drive tape is ready.
Clock synchronized?
The clock is synchronized.
Error buffers checked?
The error buffer is checked.
Okay. I guess we're all set. Okay. Hello, Andover. Homedale here. Yes, we're all set. Ready to go.
Fleur-Baudou, Brittany, France. Across the Atlantic, too, there is quiet expectancy. In this corner of historic countryside, months of intense activity, of consultation and construction, are focused on a few crucial hours. Here, beneath its ray dome, waits another great horn antenna, sister of the one at Andover. Across the channel at Goonhilly Down in Cornwall, the British antenna is also poised on the predicted path of Telstar. The bird. This focal point of concentrated attention on both sides of the Atlantic will be the first active communication satellite in space, if all goes well.
All stations report for communications check. Antenna? Antenna here.
At Cape Canaveral, private industry and government work shoulder to shoulder under a unique arrangement. In this project, the satellite was built, the launch bought and paid for by Bell Telephone.
Run number 4758.
Bell Labs men are old hands at Canaveral. Their job? Guidance control, putting satellites into exact orbits.
Clear plotting board. Plotting board clear. Guidance control, this is radar control. The radar is ready to acquire the missile. Roger. Radar control, stand by. We should be picking up terminal count in a few minutes. Roger.
This is spacecraft test control. All spacecraft test positions, please report ready.
Nearby, in adjacent vans, is Telstar control. The telephone men who must make certain that the sphere is in prime condition up to and through its launch.
Telemetry is ready. Console is ready. Tracker is ready.
Spacecraft advisor, this is Telstar control. How do things look in the mission control center?
Telstar control, this is spacecraft advisor. this is go. The mission director just gave a go to the blockhouse. Mission director to launch director.
The launch itself will be under the direction of the National Aeronautics and Space Administration.
On all stations, spacecraft mission is go.
On the blockhouse firing line, a fourth team. Again, NASA and Douglas Aircraft and Aerojet backing up the Bell system. For all, a common target, a mutual objective. Telstar receives the sheathing that will protect it in the abrasive journey through Earth's atmosphere. Launch is set for 3:35 a.m. Eastern Standard Time. The launch vehicle is the 90-foot three-stage Delta, successful in 9 space ventures. The final count is coming up. All systems are green. At all sites, the word is go. This precise moment has been a long time in the making. As early as 1954, at the Bell Telephone Laboratories in Murray Hill, New Jersey, the possibilities of satellite communications had been foreseen by Dr. John R. Pierce. Although 3 years were to pass before Sputnik 1 rocked the world, Dr. Pierce's ideas helped spark the search for Telstar. Even then, there was little doubt of the eventual need for improved means of communicating overseas. Across the United States, microwave towers dot the horizon. Great volumes of messages and TV shows can be flashed from point to point, supplementing other landlines to help provide the communication channels the nation requires. But when the ocean is reached, there are no towers. A tower in this ocean tall enough to do the job, or a string of towers, is obviously impractical. But if such a tower could fly, then Americans and all the people of the world would have an exciting addition to their communication toolkits. A ring of flying microwave towers could assure continuous overseas transmission, help meet the communication demands that are growing with each passing day. The credit for Telstar properly belongs to scientific development based on research that reaches out ahead of man's immediate needs. Telstar is the sum of many men's efforts over the years. When the need for communicating by satellite became apparent, the products of Bell Labs research were on hand to be a part of Project Telstar and to make it work. Gigantic things, like the Andover antenna, weight 380 tons, yet built with the relative accuracy of a fine watch, so precise that it can track its target within 1/50th of 1 degree. Or its forerunner at Holmdel, New Jersey. At the heart of each of these huge antennas is a special FM feedback receiver and a ruby maser, which operates at 456 degrees below zero. Together, they pick up a faint signal, only 1/1000th of a watt strong, and boost it back to a usable level. Tiny things are equally important. Transistors. Without them, Telstar could not relay messages in space, and rockets could not be so precisely directed or controlled. Solar batteries to borrow power from the sun and keep Telstar's electronic gear alive. These inventions and more, products of telephone research, were on hand when the time came for Bell Labs to put the first Telstar together at its Hillside, New Jersey location. 10,000 electronic components to go in a 34.5-inch bore. Each subassembly packed in plastic foam. The bird framed in magnesium with a shell of aluminum. 3,600 sapphire-covered solar cells mounted in platinum. Telstar reached the dust-free purity of its assembly in hospital operating room atmosphere. Nothing was left to chance. Vibration tests. Transmission tests in a simulated space chamber. solar battery tests under artificial suns. On a brilliant June day, Telstar arrives at Canaveral after its 1,000-mile journey from New Jersey. Security police form its escort. Missiles and payloads are royalty at Canaveral. Telstar rides in a special air-conditioned truck. Behind it are years of unremitting labor. It's not the things that are known that bother the scientists now, but the things still unknown. So of more immediate concern is the question, how has the bird fared on the trip south? After transfer from truck to Telstar's satellite van, a band goes around the new star's equator. Cables are attached for another tough physical. And solar cells, antenna, satellite transmission, and telemetry are checked. Okay, so far. Smoothly fitting into the timetable, Douglas starts the movement of its booster onto the launching area and into the gantry. The meticulous, time-consuming seating of the rocket on the pad begins. The bird moves to NASA's spin test building. There, it is mated to the third stage booster, that package of highly dangerous explosive that will give Telstar its final orbital speed and start its spin through space. Spring steel coils tightly, ready to thrust the bird from its nest. On the spin table, it is rotated as it will be in the sky, 180 revolutions a minute. Safe beyond dugout walls, the Douglas engineers perform the dangerous task of balancing the spinning orb and its mate to guarantee stability in space. Again, the band and the cables. Again, check and recheck. Spin test antenna to Telstar antenna to Telstar control. Check and recheck. Canned for protection and transport, the messenger of space moves on its cautious way up the gantry. Telstar weighs in at 170 pounds. Its family tree is an impressive history, for every one of its components was subjected to months of life tests, and pedigree papers were accumulated on each part. With this sort of survival of the fittest approach, Telstar should have the makings of a champion. It's $1 million baby, and every move it makes is watched by anxious guardians. Third stage and satellite lower gently to a mating with the second stage, mark to mark. Telstar travel plans include an elliptical orbit with a low point of 600 miles, a high point of 3,500 miles, an elapsed time of approximately 2 hours and 40 minutes for each orbit. Again, the cables are attached for one last examination. Check and recheck. There are contradictions in this kind of pioneering. Nylon gloves in a bare-fisted fight. Contamination is an enemy. and thundering explosive forces are subjected to minute checks. The cable is removed, a last connection made, the face of a cell fastened. The baby is buttoned up. The fairing goes on. Clamshell seal against Earth's atmosphere. Pea pod to be tossed aside in space. No more check and recheck. Telstar is on its own. Day merges into night. The gantry pulls back. For better or for worse, Delta rocket and mated Telstar satellite stand alone. Now the order comes, clear the area. Only launch personnel are left. The final count.
Stand by to pick up the count on my mark.
4 separate groups linked by a communication system. Bell Labs guidance, Telstar control, NASA's mission control, and NASA, Douglas, and Aerojet in the blockhouse.
Launch director to mission director.
Mission director here.
Would you give me the mission status, please?
The mission is go.
Roger, thank you.
Guidance control, steering checks are complete. The radar is preparing for guidance.
Roger.
Report BTL status.
BTL's ready.
Launch director, we have received clear to launch.
Minus 50.
Start remote camera number 1.
Started.
Close blockhouse vents.
Close. Console, start camera and mag tape recorders. Camera and mag tape on. Minus 10, 9, 8, 7, 6, 5,
Solo fuel.
3, 2, 1, 0.
BTL's tracking. Tracking okay at BTL.
Plus 70 seconds.
Mark. BTL tracking first stage. Guidance. Okay. On course. Pitch up signal at this time. And little all right. Looks good in azimuth. Still a little pitch up. Sequence 2, sequence 3, sequence 4. Separation? Very good.
Spin up and burnout have been reported.
Andover, this is Telstar Control at Canaveral. We've got good news. Downrange station Antigua reports third stage burnout scene. Doppler track at the Cape looks good. I think we've got our orbit. We'll keep you posted as to what we see.
Roger. We will initiate test series on 5th pass.
When pinpoint orbit was assured, Cape Canaveral said to Andover, "We put it up there. Now you find it and talk to it." The big task begins. Command tracker, precision tracker, bighorn, fasten on Telstar's predicted path. Seeking, searching for an infinitesimal speck in space, racing along at 16,000 miles an hour, like finding a golf ball over 200 miles away.
Director, this is ground control. Mission state established. Roger.
Station is in mission state and search condition.
Operators hold on this line pending satellite expected rise time. Sending station identification.
The satellite is rising over the horizon.
We have a detected signal. The command tracker has acquired. Roger, the telemetry just went into lock.
Bullseye. Andover is dead on target. With the newsmen of press and television looking on, the experiment is out in the open, in the American way. Fail or succeed, the chips are down. Fail or succeed, the presses will roll, the television cameras scan the event. Will Telstar work? In Washington, DC, distinguished guests wait and watch expectantly before a large closed-circuit TV screen. Vice President Johnson is there, with Mr. McNeely, president of AT&T, and Senators Kerr and Smith, Congressman Miller, Harris, and Albert, Senators Dirksen, Symington, Magnuson, and Pastore, and Administrator Webb of NASA. And the Federal Communications Commission watches the show at Andover. The first test is coming up. Will Telstar receive a telephone message from Earth, amplify it, and return it to Earth? F.R. Capel, AT&T board chairman, will speak with the Vice President of the United States. The connections go in.
Good evening, Mr. Vice President. This is Fred Capel calling from the Earth Station at Andover, Maine. The call is being relayed through our Telstar satellite, as I am sure you know. How do you hear me?
You're coming through nicely, Mr. Capel.
Well, that's wonderful. Since you're also head of the Space Council, Mr. Vice President, I suppose you followed with considerable interest the activities today which have resulted in this call. The first telephone message in the world, as a matter of fact, over an active satellite.
Indeed, I have, Mr. Capel. The progress of the satellite from the time it was launched early this morning from Cape Canaveral by the National Aeronautics and Space Administration has been most gratifying to all Americans. I'm sure millions of them have been proud of this achievement, which is another first in our conquest of space.
Well, I think the people of this country are pleased with this demonstration of cooperation between government and private industry. The teamwork this morning at Cape Canaveral, which I witnessed, was outstanding.
I quite agree, and I think this is a matter of satisfaction for every citizen of the nation. I'm certain that the results of the Telstar tests will be most valuable in providing some of the knowledge needed to bring into operations a very fine commercial communication satellite system.
Well, we're most hopeful of this, and certainly pleased at this performance so far. Good night, sir, and thank you a great deal.
Full steam, Andover plunges into a second big question. Can Telstar handle the special requirements of television? The picture goes out into space. The answer lifts American hearts. Then a bonus, a surprise, an unexpected first.
Capture, have they been on the Joe? We just get an announcement right now. The French station has the picture. It's an excellent, clear picture.
You mean we've made an international telecast?
We've made an international telecast.
Well, let me congratulate you.
Then a photograph of Telstar is transmitted to the satellite and sent back to Earth. The first facsimile transmission. Next, two 500-word stories flash from Earth to satellite to Earth. Tape punching out news. Data transmission at over 1,000 words a minute. The following day, Telstar brings a voice and a face from France to the television sets of the United States. The next Telstar pass, we receive the dry understatement of our English cousins.
On my immediate left, I have John Taylor, who is in charge of our space
research and development.
The first international telephone calls are between AT&T President Eugene McNeely and communication officials in France and England. In an historic first, President Kennedy's news conference is televised overseas.
I understand that part of today's press conference is being relayed by the Telstar communications satellite to viewers across the Atlantic, and this is another indication of the extraordinary world in which we live. So we're glad to participate in this operation developed by private industry, launched by government in admirable cooperation.
Telstar is a scientific success. More than that, it carries with it, through space, the hope that someday all men will see and talk to each other as friends.